Hi, in this video we are diving into a world of querying in JavaScript, exploring it practically and with many use cases. We'll start off with some simple definitions and examples to get the concept, then move on to a more advanced example. We'll start to rewrite a very famous and familiar open source library, one that you likely used before, and see just how much more challenging our task would be without querying. So stick around and join us on this journey. Querying is process of reshaping this to this, or querying is a functional programming technique that involves breaking down a function that takes multiple arguments into a series of functions that take one argument each. Alright, let's see a simple example to better understand the topic. In this example, we have a function that we want to use as a calculator. This function is quite simple. It takes three parameters. First number, which is a number operation, is a function representing the desired operation, and second number is another number. The logic of the function is also straightforward. It takes the arguments we pass to it, calls the operation with the numbers, and returns the result. And I'll define the operations here also in an object so that we can use easily and pass them into the function. Now we can call this function like this. Now imagine we want to have a calculator that is somewhat realistic, and we want to use it in a UI structure similar to real calculator. The user should be able to enter numbers and desired operations step by step and see the result after completing these necessary steps. In a sense, we need to pass our arguments to this function step by step. So, one solution to this challenge would be querying. So let's do it. First, we need to write the queried version of our function. Okay, now if you take a closer look, we're not doing anything specific in the functions we wrote instead of returning. So we can remove the return and curly braces and simplify our function. One thing to pay attention to here is that we are using closure and our function has access to previous parameters. This is what makes querying very useful. Well, that's all well and good when we are defining the function ourselves. But what if when we are using a third-party library or a built-in functionality? In that case, we can still write our code in the same way and finally call the desired function, which will work the same. Additionally, if you have ever used functional programming utility libraries, you may be familiar with a utility function called query that takes desired function and returns its queried version. And that's it. That was all possible ways you can query a function. Now let's jump to a challenge to see how querying can help us inside real world. Alright, let's dive into an example together to better understand the topic and see where querying can be useful in our project. One really handy application of querying is in middlewares. Imagine you're working on a library like Redux, but you want your code to have abstraction layers and middleware capabilities. You also want others to be able to customize the logic as middleware for your library. Let's start by coding a simple Redux-like setup to lay the groundwork for the explanations we have. In this example, we'll only implement the essential parts. Redux creates a global store and provides us some methods to update that store, dispatchers and subscribers. It takes a reducer and initial state from us to do so, For this, we use a function called createStore. Let's go ahead and create this function. Given the input and output we are familiar with, we know that the shape of the function should look like this. It takes a reducer and initial function and returns methods like dispatch and subscribe. And inside, we should have a variable to hold the state. To simplify this, I won't implement the subscribe method, but here is a brief explanation. The subscribe method's job is to take the functions, callback functions, that need to be called after a state change and store them in the listeners array here. I'll also assign the initial state here myself so we can focus on what's important. Now let's finalize the dispatch function. Contrary to its name, this function is quite simple. It takes an action with the state it has access to from closure, then passes them to reducer. And after that, it updates the state with the output of the reducer. After that, this function should call the subscribers, which we haven't implemented here. So now this function is ready for us to work with. And let's define a reducer that has only two actions, increment and decrement, tested out and left to the console. All right, now we want to create a middleware. A middleware is a functionality that has access to necessary utilities and functions to control the main functionality. When we use a middleware, we are essentially in communication with middleware and not main logic. And it's middleware's responsibility to execute the main functionality. In our case, main functionality is Redux. Okay, now let's create middleware function and let's clean up here a little bit. I'm going to change this to a store to use it inside our functionality. So based on this assumption, we know that the middleware needs access to state and dispatch function. And on the other hand, we should be able to pass actions to it for execution. Okay, let's move forward with this assumption and try the middleware. We don't have the outputs for now. We'll define them later. So in this middleware, our goal is log each action before it dispatched and after it. For this purpose, we have our loggers to set up and we call our dispatcher that we have. And here we needed to get a state function to have read-only access to a state outside the function. And now in order to use it, I should call the middleware with action and I should pass the store as first param to our middleware. And let's run it to see if it works or not. And I should delete our log here that because it was for the test purposes. And you see it, our middleware is working now. It seems we have a small problem here. As you can see, I realized that I need to pass the action right where I apply the middleware. Essentially, wherever I want to use the middleware, I have to import everything from Redux and pass it to the middleware and actions as well. But we need to apply it once, use it everywhere. To solve this problem easily, we can use coring. By coring the middleware, we can apply it once, and now our middleware has access to what it needs. Then we can easily dispatch any desired action wherever we want. This is exactly the application of coring we discussed. Not only can we apply the middleware once and use it in other module, but we've also added a very useful feature to our code architecture, and that is effectively managing abstraction layers. Applying the middleware is something that should be done in the application level, while dispatching should be done at the module level. And this aspect has been well implemented here. All right, let's continue. Let's write another function called apply middleware because we missed something out here. Remember, if we want to use multiple middlewares, what do we do? For this, let's change the middleware so its results match exactly what Redux produces. This way, we can control it with another middleware. Cool idea, right? And this function takes the middleware function. As you know, the middleware already returns dispatch. To make it similar to the Redux, our own Redux, we just need to add the store along with dispatch to the output. And let's give a better name to our middleware and move it up here, and that's getting up. And notice that we have two sections of code here. The top section is what we have inside the library, and bottom section is what user should implement to use our library. And let's just apply one more time our middleware into the store to see how can we use nested middlewares inside each other. Let's keep going and we can add as many middleware as we want. Now looking at how we have implemented this part of our code, we see that it's a structure we can compose with piping or composition. Here I don't want to delve too much into the piping, but let's understand it to this extent that it's a method where we can combine several functions together so that the output of one becomes the input of the next. And finally, this function gives us a new function that combines all the input functions. But here we have a small problem. To perform piping, the function we want to pipe must have the same input and output types, which should be of the store type here. But our apply function requires both middleware and store as an input. This is exactly the problem we want to solve with querying. That's a great example. Here we are doing one of the most useful and coolest things functional programmers do with querying, and that's synchronizing and preparing functions for use in piping and compositions. This means shaping the function so that it can be used in pipes with other functions, transforming it to fit with other functions, and then using it inside a pipe. First, we need the piping function. If you have worked with functional programming utility libraries like Lambda, they all have this function. I'll quickly create one here. This function takes an array of functions and returns a new function, which we can call then with an input. This function takes our input, calls the first function with it, and takes the results and pass it to next function, and so on. I think that was quite enough explanation for piping and composition in this video, but if you like to delve deeper into piping and composition, let me know in the comments and we will cover these techniques extensively in a separate video. Let's continue and pipe our function together. To be able to do this, we need a function that takes the store as an input and also returns the store as an output. However, when we look at the apply function, we see that requires two arguments, middleware and the store, and it returns the store. Now, how we can shape this function to the way we want? Well, the answer is coding. Let's do that. Now that function looks the way we want, we can use it in our pipe. Now we've done this, also we can use our middleware inside the pipe and get a new function that we can pass our store to, and all those middlewares will be executed within it. And now let's finish it by commenting the old parts we don't need anymore and use our pipe middleware to dispatch and test to see if it works or not. Then, to make our code even more elegant, we can separate You can separate the application process into a separate function and create a new function with a name that reflects its purpose. As you can see here, we've gone from imperative coding to completely declarative coding. And that's what we love about functional programming. Instead of saying how to do something, we say what to do and what I need.